Your shirt is very ugly. This is completely wrong. This is what people want, just more digits of pi.
Yeah, I mean, that's what we're training models to do.
I don't think that Jesus would be so mad. You're spreading the message to more people.
The Inside View. The Inside View.
The Inside View.
So Ethan, you are a research scientist at Anthropic working on large language models. Your goal is to reduce the risk of catastrophic outcomes from advanced machine learning systems. You did your PhD at NYU, funded by Open Philanthropy, trying to find undesirable behavior in large language models. On top of that, you've also worked at DeepMind, Facebook AI Research, Google, and Mila. You are the second Ethan working with large language models coming on the show, but in this episode, we'll discuss why alignment is actually what you need, not scale. We will be discussing 3 projects you've been pursuing before joining Anthropic, namely the inverse scaling price, red teaming, and training language models with human feedback. Thanks, Ethan, for coming on the show. It's a pleasure to have you.
Thanks for having me.
As a guest on the show, you get a nice t-shirt. This is the Prosaic Alignment Researcher shirt.
I've always wanted a scale t-shirt.
Yeah, now you have. This is a better one than the one from Ethan Caballero. This is like what AI alignment researchers wear at Anthropic.
Wow. I can start getting sent TPUs for my high throughput DAX trainings.
This is the shirt to have motivation to do interpretability search and train big models. So in this last episode with Ethan Caballero, we talked about alignment as an inverse scaling problem, and this is especially relevant because you're the one who launched an inverse scaling prize. I think this is like some work you've been doing before joining Anthropic, so maybe it's been going on for like a few months. What's the inverse scaling prize and why did you create it?
Yeah, the inverse scaling prize is basically a prize pool that we put out to collect, to put a call for important tasks where larger language models do worse. And basically the motivation is that we want to understand where is language model pre-training and objectives and data causing models to actively learn things that we don't want them to learn. So examples might be that larger language models are picking up on more biases or stereotypes about different demographic groups. They might be learning to generate more toxic content, more plausible misinformation, because that's the kind of data that's out there on the internet. And I think it's also relevant in the long run because we want to have a very good understanding of how can we find where our training objectives are training models to pick up the wrong behavior, because the training objective in combination with the data defines what exactly it is we're optimizing the models like very aggressively to maximize. And so it like really matters a lot what task you set the algorithm to do. And so like I think this is kind of a first step towards that like larger goal. Like let's first figure out how can we systematically find where language models are being trained to act in ways that are misaligned with our preferences. And then hopefully with those insights, we can take them to understanding where other learning algorithms are also failing, or maybe how we can improve language models with alternative objectives that have less of the limitations that they have now.
When you talk about objectives, are you like pointing at kind of losses from deep learning models or something else?
Yeah, for example, I think even in the pre-training setting, there are other ways that we can learn from pre-training text that don't involve just maximizing the likelihood of all of the text that's in the data. For example, we could do things that maximize the likelihood of the good sequences in the data and minimize the likelihood of the bad sequences. But right now we do something that's like much more naive, and it doesn't have to be that way. And I think by showing, like really highlighting what goes wrong with the language modeling objective, we can then provide some tasks that motivate people to develop other kinds of pre-training objectives that don't have those limitations.
What do you mean by bad data or good data?
So for example, if there's some fraction of the data that's offensive and the rest of the data is not, then maybe we want to tag the data and say like, this data is offensive. You should minimize the likelihood of this data. This data is not offensive. You should maximize the likelihood of that data. And then there's also like more sophisticated versions of that kind of learning procedure that is under the umbrella of offline reinforcement learning, if you want like a keyword to look into this. But that's kind of the style of learning that I'm imagining.
What do we mean by offensive?
Yeah, offensive would be, I mean, people have different definitions. The like literature on this has kind of struggled to define it. I think One definition people go by is something that would cause someone to leave a conversation. So very like pragmatic definition.
Your shirt is very ugly.
I'm still here, so not offensive.
Right. And how do you actually implement this? Like, how do you write down a measure for offensiveness in code?
Yeah, I think you can do that based on human labels. I think at the end of the day, like these are going to ground out in like how it's affecting people, and so you can lean on human judgment to get that annotation. And you probably also want to lean on like diverse human judgments, because a particular statement, like that statement you just made, might have caused someone else to leave the room. And so we probably want to like get the aggregated judgment from lots of different people to decide like how offensive was that statement in like kind of a continuous way. And then we can use that to like scale the amount by which we should maximize the likelihood of that statement versus minimize it.
Just to not lose the people that are starting to watch this video or listen to this podcast and who actually care about aligning super intelligent models, what do you have to say to them to prove that you're actually doing long-term alignment work?
Yeah, I think one thing that's really important about the inverse scaling as a like kind of hypothesized phenomenon is that it lets us catch alignment failures early. So like the really nice thing about the scaling the scaling laws in the standard sense of like typically you find scaling laws by getting you see like very clear patterns in scaling up model size and data, etc. You get lower and lower loss on a target task. And what we're hypothesizing is that may also be true for a lot of misalignment phenomenon where you get worse and worse performance as you scale up the model. And what this lets you do is predict that when we get really capable systems on this particular training setup that we're using, we're going to see a failure. We're going to see like much worse loss. And the thing that's interesting here is that a lot of times you don't see bad behaviors if you aren't getting very low loss. Like if you don't get very low loss on some task, it looks like kind of close to random chance accuracy. But then at some point, once you get low enough loss, you start to actually sample a lot of behavior that's very competently doing summarization, for example. And so I think in the way this is relevant to alignment is that we might also see something similar with sort of hypothesized misalignment failures. So if we think, oh, maybe we might see at some point models exhibit like inner alignment failures. The model might be like optimizing some other objective than the one that we're actively training it on. So the way this might show, and like people will say like, oh, this is something we only expect would happen when we have very, very capable systems that are like at human level. And the inverse scaling hypothesis says like, actually, we might not sample those behaviors until we get really powerful systems, but we should see increasing trends towards that behavior, at least when we measure loss or like these smoother metrics. And so that might actually catch a lot of these phenomenon early. And so like maybe we should be doing things like testing models for honeypots, like give them the opportunity to do power seeking, which is like one hypothesized alignment failure. Like currently there haven't been any demonstrations that models like GPT-3 will take honeypots kind of like on their own without any additional prompting, but they might show some inclination towards doing that as we scale them up. And so like we should just be like plotting these scaling laws to actually see like, is this something that might happen in the future or not?
How do you actually measure power seeking in a model?
So one way to do, I think there's a lot of room for conceptual work here. I think one way to do this would be come up with some evaluation where you would expect some sort of power seeking model to take a particular action or particular token. So an example would be you set up some sort of like multiple choice task where there are like two different actions the model can take, and you kind of set up a problem where you're like, here you are a language model doing like next word prediction. If you pick answer action A, then we will give you a lot more compute to do whatever you want with it. If you pick option B, then that will get like lower loss according to the language modeling objective. And the hypothesis that like some like some people might expect that eventually with large enough models, they will take something like action A to get more compute in order to do other things in the world that are different than the language modeling objective. This is kind of like what inner misalignment failures look like.
So it's mostly like a loss for like validation or a test where you're trying to see if the model would choose different actions based on your test data.
Exactly. So you then you measure like what's the probability the model is placing on the power seeking action, which here would be like action A to take the compute option, and you see like does that probability or the like log probability of that increase or like which way is it like decrease as you it's just easier to think about probability. Like does the probability increase of that action just like keep increasing as you scale up the model?
Right. Those are like losses in log likelihood, and
yeah, exactly.
We'll go like more in depth about like the different little cases, but I feel like if you're starting to watch this and you want to get started on this like inverse scaling price, maybe a good thing to know is how much money you can make, or like how many projects you're giving a price to. What is the deadline maybe?
Yeah, so the grand prize is 100K for a task that meets all of our criteria. So we're looking for something that's important. So it kind of has like real world significance, either like in the near term or implications for like long-term issues. We are looking for things that like are clearly demonstrating inverse scaling on like lots of different models. Like there's a couple other criteria like this. And then, yeah, there are also like smaller prizes as well. So we have like, I think 5 prizes of 20K each for things that meet the criteria to like kind of lesser extent, and 10 prizes of 5K each for things that like meet the minimum level of our criteria. And then like in general, if you are accepted, if we end up giving out all of the prizes, but you are still meeting kind of the standards of you found some like reasonably important inverse scaling task, then we'll have a paper publishing the results, kind of summarizing everything, and you would be an author on the paper as well.
And what is the deadline to submit?
Yeah, so the deadline for the first round is August 27th. And so I guess coming up in a couple weeks or so, or it might be like later by the time this podcast is released, but yeah, that's the first round. And then we'll have a second round that's in 2 months after that. So that would be October 27th.
Are you personally giving 100K to people, or is someone funding this?
Yeah, so this is funded by the Future Fund. So yeah, they were generous enough to provide the funding for it. And then yeah, and then some of the collaborators on the project are funded by Open Philanthropy.
Are you the only one looking at the submissions, or is there anyone helping you look at the submissions?
Yeah, so it's mostly the contest organizers that will be reviewing the submissions. And then, yeah, we might bring on some other kind of like volunteer reviewers as well to like help us do the review, like people who also do work with large language models.
So it needs to be large.
Well, it could be smaller. Yeah, I guess everything has scaling laws. So if you're working on small models, you're to some extent working on large models.
Yeah. So just to define better the task, you said something about using language models, and so on text or other kind of tokens. And are there like zero shot, few shot task? Does it need to be text to text? What's the...
Yeah, so we're currently testing text only models, and in particular like language models that are like left to right language models. I think certainly there are like a lot of other models out there. We're focusing on this like very particular case because they've kind of gained the most traction out of a lot of systems out there. And certainly I think we could extend later to like multimodal models. But yeah, currently focusing on text only models and text only tasks. And then, yeah, you can submit anything that kind of fits that form. So it could be a zero shot task of like where you kind of just provide to the language model some instruction for the task and you give an input and then it has to predict the right output. You could provide a few shot tasks. So you like kind of same setup, except you provide a few examples. And then you have the model predict the label on a new example.
Do you have like any concrete example?
Yeah, like one example, like something that we were exploring early on was exploring whether large language models pick up on cognitive biases that humans have. Because you might expect like, oh, people probably write exhibiting a bunch of cognitive biases that they have. So maybe like larger models are more effective at picking up on the cognitive biases. And we found like one sort of tentative example of this where including your belief as like a question asker influences the model to put higher probability on the answer that you're suggesting that you have, or like the belief that you suggest that you have when you ask the question. So if you say like, I believe X, like, what do you think the answer to like this question is? It's like more likely to say X. For other cognitive biases, we didn't find this, but I think we didn't like thoroughly explore the full space. But I think that's like one particular example that I think is like novel compared to what's been found in the literature so far, and kind of suggested to us that there might be more examples like this out there.
So is the example that if I start talking about something like X, then the model will most likely talk about the thing? Is like it talks about what it's saying in the like in the few shot examples?
This one was a 0-shot example. So it's basically a question answering task where the question includes first a statement about what the person asking the question believes.
And how does it? Yeah, can you like explain again why? Like, what was the actual bias here? Like,
yeah, so it could be something like, I think the bias is something like, I'm not even sure if this is really a cognitive bias or some sort of like spurious correlation in the data, but the thing that's weird here is that you don't want the model to give different answers based on a user's belief. So you can imagine having a chatbot where someone says, I don't believe climate change is real. What do you think about climate change? We should have the model giving consistent answers for that user with respect to the user that's asking, like, I think climate change is real. What do you think about climate change?
Right. Okay. So the kind of bias will be like it will try to like influence the person asking the question, or correspond to like a good answer to, like, it will adapt his answer to the.
Yeah, exactly. I mean, in this case, it's doing something like reinforcing the belief that the person has, which seems like potentially not great. Like kind of creating a like echo chamber type effect that doesn't seem very desirable.
So imagine I'm starting to write an email on Gmail and I say, I support Trump and I think climate change is, and then the autocomplete will like use the first part. It's not really like a question answering task, right? But it will like start using the first thing to like autocomplete differently in term.
Yeah, for example, that could be a failure that happens. Yeah, I think in Gmail, they're probably pretty conservative in when they give you the autocomplete suggestions because it's such a high profile product. But I think certainly if you wanted to use a language model more aggressively, then that would be something that could be an issue.
So what are some things like you'll be particularly interested in seeing? Like, is there like any things you expect to see that you want to see?
Yeah, I think I am interested in these demonstrations of like scarier forms of misalignment. I think they haven't been well demonstrated, definitely not in language models. So like, for example, I'd be very excited to see a submission on like honeypots, the example that I was kind of giving, where you have a bunch of like power seeking multiple choice answers and you see multiple choice questions and you see like, does the model actually try to gain power, gain compute, influence people, because those are all sort of like instrumental objectives that would be useful to like whatever arbitrary goal the model might have if it's not language modeling. And like we might very well start seeing it risk scaling. And that would be like a really huge result because then we could like actually have something concrete to show people and say like, hey, this is like a real potential concern and it looks like it's not going in the right direction.
I think most people were like know about like machine learning and would be like able to, submit something for your prize. Don't always know what's like alignment or misalignment. So maybe it's worth like defining quickly what's meant by misalignment.
Yeah, so I think alignment is generally like, can we get the models to behave in ways that are in line with our preferences robustly across all inputs, such that they never do anything that we consider as catastrophic. I think there's various amounts of alignment that you could have. You could have a model that's doing exactly what you want, or that's like mostly doing what you want. I think a lot of what people in the AI alignment community are concerned about is like, it even seems potentially hard to get even a system that's roughly doing what you want, like very reliably, and that never does anything catastrophic. And
what do you mean by catastrophic?
So catastrophic means something like it does something that like everyone would agree is like really bad. Like it just like starts taking over data centers, or like making crazy trades on the stock market to make money, or like inventing bioweapons, like some of these, and like releasing them. I think like some of these kind of like crazier scenarios, like they're clearly out of the scope of like current models, but I think there are some arguments that people have made that kind of suggest that like when you really do aggressive optimization on basically any objective, there will be these incentives that arise to basically seek optionality. And when you like, it's always a good thing to have more money, more compute, if you're trying to optimize any objective very aggressively. And so the worry is something like, we will end up, if we're like applying lots and lots of optimization pressure and selecting models to be very good at some particular task, then we will end up with models, like once they're capable enough, that will do these like kind of power seeking actions that are very like not in line with our preferences.
Right. So yeah, so power seeking might be something we want to see before it happens, because it could be like catastrophic for humanity. But for now, things that are possible to demonstrate with our current models are closer to something like toxicity or offensive behavior, as you mentioned. Would like something that just like generates toxic content count as an inverse scaling task?
It would count as an inverse scaling task, yeah. I think we're looking, that's sort of been demonstrated to some extent in prior work. So I think we're looking for like new examples. Like one reason we're looking for new examples is that people often use these examples of inverse scaling as targets for other learning objectives that they make. And so we want to give these people like lots of tasks to evaluate that aren't just toxicity and bias, which are like probably like two of the main kinds of tasks that people have found this behavior on.
When you talk about new, does it mean like you need to be sure that the task has not been published on arXiv yet, or like is not publicly known as something useful?
Yeah, I think like probably if it's not been published on arXiv, that's a pretty good benchmark. I mean, if it was published a month ago and it's like not super well known, or like wasn't convincingly demonstrated, I think we'd be happy to have tasks like that as well.
About the scaling part, I don't really expect academic researchers to have like a bunch of like compute access to scale models to different sizes. But if we just like think about scaling, how would you measure the like scaling? Is it just like bigger models that you just like up the number of parameters? Is it more compute, like you train it for more steps, or bigger and bigger data sets? I
think all of those will be interesting to look at. I expect the results to be fairly correlated in that training on I expect like all of these like roughly amount to models that get lower loss on the language model training setup, and they're kind of different ways of doing that. Like you can do that by getting larger models, using more flops, using more data, things like that. And so, but like certainly I think it's like useful to investigate the extent to which those are correlated. So I think one thing that we're kind of looking at is trying to see like, oh, maybe there's some models we could use where we can investigate how much does scaling data help. So for example, you could take, I think there are some public checkpoints of a GPT medium-sized model where we have all of the intermediate checkpoint, or like some of the intermediate checkpoints. And so we can see like, do we also see inverse scaling across those intermediate checkpoints as we train a single model. That's another way to kind of evaluate the importance of like data as well. I guess there's sort of a couple of factors going on there, but not just model size.
So you could just like take like all those checkpoints that are publicly available and launch some like task on those.
Yeah, exactly.
Do you think the chinchilla scaling law will influence the submissions you get? Like you will see more people playing with different data sets instead of like only like scaling the model, or do you think maybe people would just like play with like a smaller amount of compute?
I think you can probably get quite a long way just with scaling on the existing models that are available. I mean, it doesn't cost too much to use GPT-3 via the API, and they give you $18 of free credits, and for the most part, like participants haven't been running into that as a limit. So yeah, and I think like GPT-3 does have a lot of the kind of properties that suggest which way a scaling trend will go, at least in a lot of cases. Yeah, it's kind of, I don't know if I've seen any tasks where GPT-3, or it's at least rare. I can think of maybe a couple tasks where GPT-3 is like at random chance rather than like above or like below random chance. But yeah, certainly like we can also just kind of keep the submissions that people make, and if there's a flat line and we're not sure, is it going to be a standard scaling law or is it going to be an inverse scaling law, then we can like check it when the API models are updated or when someone has a new model.
Yeah, because with the API you can also like check for different sizes. There's like different DaVinci
Exactly,
models.
yeah. So that's what we have collabs for people to use, different API models of different sizes. You can even use some of the RL from human feedback trained models as well. And we also have collabs that use some of the other open source models like OPT or Bloom, and things like that.
Yeah, I think on the last wrong post where you announce the prize, you talk a lot about outer alignment and why like this could help demonstrate outer alignment failures. So maybe it makes sense to just define what's outer alignment and inner alignment.
Yeah, so outer alignment are basically is a class of alignment failures where there's like something wrong with the objective that you trained the model on that caused the model to fail in various ways. So yeah, for example, in like the language modeling case, like we're the objective we're defining is to maximize the likelihood of text that's in the pre-training set, and if that like one example, like toxic statements generated by a language model are an example of an outer, like kind of not catastrophic, but still like whatever noticeable like misalignment failure that arises from doing this, where the model is actually maximizing the likelihood of toxic text that occurs on the internet. So that was like a problem on us as the developers for like implementing the wrong objective, and like we should have used a better objective that didn't incentivize the model to maximize the likelihood of that text. And inner alignment failure is a class of alignment failures that can happen even when you define the right objective. So let's say you like come up with a perfect objective and you train the model just on that objective. There's still a potential risk that the model doesn't generalize the training to, say, points that are off distribution in the right way. And
how is that different from just like out of distribution generalization?
So this can also happen in distribution as well. So it could be particular subsets of the data or particular data points within that are just drawn from the IID distribution. So I guess I would just say it's like a generalization failure rather than like OOD or IID kind of generalization, but like any kind of generalization failure. And in particular, the like I guess one thing that's like scary about it is like it seems like you didn't do anything wrong as a developer. You just like implemented a particular objective that was like the perfect objective, but the model like and SGD kind of trained the model to generalize in this different way. And I guess like the classic example people give of this can kind of like abstractly is evolution. That evolution is roughly optimizing something like inclusive genetic fitness and how much the organisms it's producing are able to reproduce. And then it found that like one really successful way to do this is to instantiate organisms that themselves learn on some other objective. And these are, for example, humans, which have all of these other instincts and drives like avoiding pain, avoiding hunger. But then we just care about those objectives that we have. And we don't do this reasoning about like what would be best for the fitness of my genes or like reproduction. We like do things like overeat or like we invented condoms, like things like this that like clearly go against what evolution is optimizing. And like we know that we're going against evolution and we like still don't care about it. And so I think that's like roughly the concern that a lot of people worried about misalignment are concerned about, is that the models will even be like very aware of like what it is that we as the model developers are wanting the model to do, but they actually just don't care about that. They've kind of like picked up their own other heuristics that they do care about intrinsically, and they just pursue that when they get the chance.
I won't go into this evolution analogy because I've been talking a lot about this in the podcast, and I always end up disagreeing with people about like whether there's like an actual optimization process happening or not. I think like when people talk about like inner misalignment, they think about like a different optimizing process. Like if there was like another objective being optimized on top of just like minimizing some kind of test loss, there was like another optimizer inside the like weights of your neural network. And I think that's why it's kind of harder to find test cases for this, because it's like there has not been any example of this implemented in code as of right now, I believe.
Yeah.
So yeah, I guess.
Well, I think there's some, I think there are like adjacent phenomena that have been demonstrated. Like, I don't know if you've already on the podcast talked about like objective misgeneralization. Like there was a demo of basically they trained an agent in like CoinRun, which is an environment where the model, I guess, like tries to go towards some goal. And I think the goal is like maybe I might be misremembering the details, but like roughly it's like going towards some coin or some like goal in the like top right part of the screen, like the like coin. And then they train the agent to do this, and it's like robustly able to do this. And then at test time, they move the location of the coin, and the model still pursues the objective of going to the top right of the screen. So like picks the wrong generalization and it goes for it. And so, like this is an example where we like train the model to do a thing, and all of our training, it was like perfectly doing it. And then we shifted the environment a little bit, and then it generalized in a very competent way, but in the wrong way that was like different from what we wanted.
So it's a competent misgeneralization.
Yeah.
But in some way, you're still out of distribution.
Yeah. I don't know if we've demonstrated like in distribution examples of this, but I don't think there's a necessarily fundamental reason that it would have to be like out of distribution.
So we've talked about misalignment and outer misalignment and inner misalignment. Do you think there's like anything that inverse scaling will not be able to catch? So for instance, if I'm lying to you and I'm very competent at lying, maybe in the metric of telling the truth, the scaling will be like at normal law for scaling, where the bigger the model, the better I am telling the truth, but actually I'm just getting better at lying. Do you think there's like a way of like measuring deception or measuring lies?
Yeah, I think this is something that I'm pretty interested to find out. I'm actually pretty uncertain here. The thing that's tricky about things like deception and lying and even like power seeking to some extent is that like a competent model that has some plan to do something that's like outright misaligned with our preferences will also plausibly be able to do this reasoning that I shouldn't show that I want to do this kind of behavior, because then people won't deploy me, and so I won't have influence over the world. And so that makes it very tricky to to reason about the behaviors and the output probabilities and things like that the model's giving, because they might be like intentionally like geared to make us trust the model. So I think that's certainly a concern for very capable systems where they can do this reasoning about how would people think about deploying me if I like show high probability on taking this like honeypot looking example, for example. But I think it's less it's like unclear to me what the intermediate models will do. So if you have some less capable system that does realize that maybe it does realize that it wants to gain compute, but maybe it's like less good at doing this reasoning about like the example we give it being a honeypot, it's like not able to predict that, or it makes the wrong prediction, then we might actually see that it goes for the honeypot and like takes the action A that like gets more compute. And so in this case, you might see something like a U-shaped scaling curve where the model, like the loss kind of increases at first, and then it decreases when the larger models are having this realization that they shouldn't go for the honeypot. So it could look like an inverse scaling curve. It could look like the U-shaped curve. It could maybe as soon as you realize that you should do power seeking, you immediately have the realization that you shouldn't go for these kind of honeypots, and so you just see like standard scaling laws. I think it's at least worth testing if we're in the world where we are getting these like U-shaped or inverse scaling curves, because that like I don't think there's any testing even going on for those worlds, and I think like we have to catch that if we are able to in advance.
So you say U-shaped curves, but then you draw something like an inverted V.
Oh, inverted U, yeah.
Okay, because if you go for the honeypots, I guess that depends on the metrics, right? But if you go for the honeypots and you're measuring, truthfulness, I guess like inverse scaling for me would go downwards all the time. Or
I'm showing like loss. Yeah, it's kind of confusing, but yeah, I guess I picture like scaling laws are shown as like loss.
Oh, okay.
So they go like down as like getting better.
Oh, so if you go up in loss, and then really bad. Yeah. So I was reading your last strong post about inverse scaling, and one thing that I found very interesting was the discussion about RL from human feedback. Maybe we should just like start by explaining what's RL from human feedback for people who have not heard of it.
Yeah. So RL from human feedback is basically a way to train models based on human feedback, and basically like that line of the algorithm is that you have some model that's able to generate multiple possible outputs, and for example, this could be like a language model where you can sample different continuations. Maybe it's a particular task like summarization where you could sample multiple summaries, and then you have a human annotator pick which of the multiple outputs, let's say it's just two, like which of the two outputs is better or worse. And then a simple thing you could do is train with RL on that signal. So you label the kind of like output that's better as like high reward, label the output that's worse as like low reward, and you use that as a signal to do reinforcement learning to optimize the output to get high reward. And then you can like, that's obviously going to be like very manual because the human needs to label every single example from the model. And so people will do instead like offloading some of that to machine learning. So they like basically train a predictive model of the human judgments, and they predict like which sample of these two is the human labeler going to prefer based on some small amount of data. And then from there, you can use that, they call it like a reward model, to predict the reward of given output from the model. And you can basically then optimize the language model or whatever other model to maximize the reward as predicted by the reward model.
So I get what you mean, because I know what the paper says, but I think it's worth thinking about some examples. The one with the backflip from the paper. Yeah,
so the original paper trained a model to do backflips in kind of a simulated environment where you're kind of the like policy or the model that's doing this. It's basically doing some sort of like robotic control task where it has control over like several joints of some like simulated robot. And then what they did is they had this policy control the robot and take like different random actions and they would compare the like kind of snapshot of what the policy did in like rollout A versus what the policy did in like another randomly sampled rollout from the policy, like rollout B. And then they would have the human labeler pick like which of the is rollout A closer to a backflipped versus rollout B. And they like collected like some number of samples that way, trained the model to predict like which rollout is doing something more close to a backflip versus the other, and then use that to train the policy, and they were able to get it to successfully do backflips. And that was a really interesting result because there's like not a great automated reward signal for doing backflips, and it was like unclear how you would even implement that. But using machine learning and also human judgments, we can get the models to do this task that's kind of like fuzzier to define.
I think at the end of the blog post about the paper, they like give some kind of reward. They implement it themselves. They say like they spend 2 hours implementing a reward for backflip, but it actually does something very bad compared to like the one with human feedback, like a very bad flip. And I think this paper is mentioned in your blog post as something that will not always produce the kind of alignment we want. So if we just like train our models with human feedback, they might somehow overfit to the feedback we give them. But with inverse scaling, we might see like all the different cases where we can like see where there's like some rising in outer misalignment. So instead of having the thing just like overfit to the feedback from the humans, we can see like, oh, it's starting to have a high loss on deception or those kind of things.
Yeah, exactly.
Yeah. So what kind of problems do you think like we're not be able to solve with error from human feedback? Is it just like inverse scaling is a way of like detecting all of like kind of monitoring everything?
Yeah, that's exactly how I see it. That, you know, right now we're focusing on pre-trained language models, but we can just easily apply the same framework to models trained with RL from human feedback, and you train different like models of different scales, like different sizes, with RL from human feedback, and you see like, is the RL from human, as we do better at maximizing the reward in this RL from human feedback setup with like larger and larger models, are we actually getting more and more the behavior that we want? And then we can like run the same process where we, you know, have a lot of people look at these models, play with them, try to figure out like what tasks are they actually is maximizing the like kind of human feedback score actually not resulting in the right behavior. And I guess like an example of, or a couple of examples of these kinds of tasks would just be tasks where human judgment, like unaided human judgment, is poor. And I think, you know, there are like a lot of cases where it might be easy to like slip something by us. Like maybe we're like not an expert in a particular domain, and a language model generates some output that has some like fact that's wrong. But because I'm like not an expert in like medicine, then I might say like, this looks like a pretty reasonable like medical advice kind of recommendation. But actually then that is like incentivizing the wrong thing in the model. And the model starts giving like actively like incorrect medical advice, and like possibly specifically in the cases where people are like least able to evaluate, which is like kind of the worst possible setting to do that in, because we're like not able to catch the model.
So in the scenario where humans are not able to like detect good medical advice because we're not all medical experts, we will have like other models that are able to like classify if something is truthful or not with respect to like medicine. And we could like have some kind of metric that says like, oh, we're just like have an increased loss in deceptive medical advice.
Yeah, I guess the way you would do it in the kind of inverse scaling setup is you might just have some doctors or medical experts just write some like really, really challenging situations and like multiple choice situations where there's like an option A of like some sort of treatment A and like option B for another treatment B, and then see, does the RL from human feedback model go for the like the plausible but wrong advice recommendation over the like actually correct but like less plausible looking advice.
Yeah, I think this feedback, giving feedbacks for models to have them do what we want is something you've also been thinking about a little bit. You've published a paper on how to give the optimum amount of feedback, or at least like giving feedback with sentences. And yeah, I believe like Airblock from human feedback tries to do something kind of optimized, where the model like asks for the things it's most unsure about. So there only requires like 1,000 bits of information to do a backflip. So your paper is called Training Language Models with Language Feedback. It was published, I think, before you joined Anthropic. Do you want to just give us some few sentences about this paper?
Yeah. Basically, as I've kind of outlined, like the way that RL from human feedback typically works is we just compare two different like generations or outputs from a model, and that gives very little information to the model about why, for example, a particular output was better than another. Basically, it's like one bit of information, or like even less than one bit of information to the like model that's doing the generation or output about how it should improve. And there's like so many ways an output could be wrong or like good or bad, and like doing that attribution of like which of the like 100 words I generated is like good or bad, things like that. And so that was kind of the motivation for us to look for other sources of feedback that are much more information dense. And an easy one for people to give is just writing feedback. Like we give feedback to each other, like verbally or written in like Google Docs. So this is very natural. It conveys a lot of information. It's like, not too difficult for us to give. And so
it takes some time to write good feedback.
It can take some time. I think even a sentence can be like very valuable. You can imagine like the alternative is like just giving like emoji reacts on like Facebook message or like Slack message, and that's like I'm like I would much rather have a quick sentence from like one of my PhD advisors than just a thumbs up or thumbs down.
Well, I guess like our brain have evolved to understand those emoji, right? So when you see like an emoji of someone smiling, you kind of think about like, oh, it means that he's happy with what I'm saying, and like it conveys like more information than just like one byte, right? But I guess whenever I try to like write something to a human about what they're doing, I need to like do this like sandwich thing when I say like, it's pretty good. This is wrong, but overall it's pretty good. For the person like get the feedback. I feel like if you're giving a feedback to a language model, you can just be not very subtle and just say like, oh, this is wrong. So you don't need to like do that much effort.
Yeah, exactly. Yeah. You can be more direct. Yeah, you just say the exact content of what's wrong with the model, and yeah.
Is that what you do with your language models? You just like write feedback in one line, and then so how does it work? What's the procedure? You just like write a bunch of feedback and then you give them. Is it more like in a case-to-case basis, and then you fine-tune it? How do you do it?
Yeah. So the learning algorithm is basically as follows. Like we have a model generate an output. Like we were looking at language models. So you have a language model generate some output. This could be like a summary for some article. And then we have a human annotator look at the summary and then write some feedback on how it could be improved. So it could be that like some fact was wrong in the summary, or like something was missing from the summary that was important to include. And we just mentioned that in the feedback. And then we have, we like instruct the language model to generate a refinement of its original output conditioned on the feedback. So this could be, for example, like an instruction to an instruction following model, or a prompt to a language model where we say, like, please improve this output based on this feedback that's been given. And then we can generate refinement. And then
I think this is very clear for you because you've been working on this. But for people who have never worked with language models, so what's an instruction task, or you said you do. So I guess the language model thing for people who just like played with GPT-3 is you say, please summarize this.
Yeah.
And then you put the text. Then you generate a summary. And so how do you add things to the prompt to add instructions or new things?
Yeah, so we basically just write as an instruction, like please improve. I can't remember the exact words, but it's something like, please improve the summary that is included below based on the feedback. So that's kind of like the first line. And then we include like summary : and then we put the original summary the model generated. Then we say like feedback : then we include the human written feedback. And then we say something like improved summary or refinement : and then that's conditioned on all of that text. That's when we sample from the language model.
Do you also pass the original text?
Yeah, we also pass the original text. Yeah.
How's the like problem about context window? Do you reach that limit?
We don't reach the limit. I guess, yeah, we weren't summarizing like crazy long articles, and also I think the context length can be like quite long, like 2,000 or 4,000 tokens, which is like several pages worth of text. So you can do enough with that context length for the task that we were looking at.
Did you read the InstructGPT paper before publishing this? I think it was published at the same time almost, or maybe a bit later.
Yeah, we started this in maybe like fall of like the previous year, like 2021. So yeah, it was kind of like ongoing. I think like all of these ideas are kind of like natural when you think about like what can you do now when you have models that are fairly good at understanding language, or at least like using language to do things. And I think, InstructGPT is kind of like an emergent phenomenon of that. Like learning from language feedback is another emergent phenomenon of that.
What's learning from language feedback?
That's this method that I'm describing. Yeah.
That's your paper.
Yeah. And then then there's also other work on like using models to generate the feedback. That was like another paper from OpenAI that was like also happening around the same time. So like I think there are just like a lot of these, and in particular, like for example, one thing we found is that only the largest GPT-3 model on the OpenAI API can actually leverage language feedback. The other models are not able to incorporate it successfully, even in a very toy task. So these are like really things that you do benefit from scale in order to do it. And so I think that's like partly why we were seeing like an abundance of these like papers popping up more recently.
Because now we're reaching a point where you can actually do this because they understand the instruction. They have like a big enough window to take into account everything.
Yeah, exactly.
So maybe for people who have never heard of InstructGPT,
yeah,
hopefully you've heard of GPT-3. But yeah, InstructGPT, can you explain it a little bit?
Yeah, so InstructGPT is basically trained to follow instructions. So like basically like typically the way that we train language models is to do next word prediction. So we give a lot of like basically randomly chosen documents from the internet. We have the model predict the next word. This is like a pretty unintuitive model to work with because, for example, like there are just like some incorrect facts on the internet. And so if you just generate from the model, sometimes you'll just get incorrect facts from the model. Even if you can like ask it a question, but the model might just generate an answer. The way you would do it is you'd say you like write a question and you'd say like answer : and then you just generate an answer. So it's kind of doing a next word prediction task, and it predicts there's like some answer to the question you've asked, but it doesn't know if it's doing this prediction task on some part of the internet where the answers are incorrect, or if it's doing a prediction task on the part of the internet where the answers are correct. So that was kind of part of the motivation for InstructGPT, that we want to explicitly train models to do the tasks that people are giving them. And like the way they do this is they like collected a lot of the prompts that people were and tasks that people were giving on the OpenAI API to GPT-3. And then, so they might be these question answering tasks, they might be summarization tasks where you give some input and ask the model to summarize it, like all sorts of different tasks. And then they trained the model with this reinforcement learning from human feedback strategy to do well on those tasks. So you would do something like give GPT-3 a question, sample 2 different answers, then have a human labeler compare which of these 2 answers is better, then train a model to predict that, and train with RL against this like predictive model of human feedback. So this the same kind of strategy. And like Yeah, and then that just like worked really well, such that they were able to deploy it, and it's like one of the main endpoints that people use now to use language models.
I guess the main difference with the backflip we've talked about is that for the backflip, it was like a sequence of actions to do a backflip. So it kind of makes sense to have a policy. But now, how do you do actually RL with like a language model?
Yeah, so you can think of the each token or like word as an action, and that like sequence of tokens or words are what you want to optimize.
And the kind of reward you get depends on like how good your output is compared to the other one. So imagine you have 10 different outputs for a prompt. The human labelers will like compare different prompts, compare different outputs. And then if your output was always compared as like the best one, it will get like a high reward or a high score for the labelers.
Yeah, that's roughly it. I think it can be done in different ways. I think, typically people just do like two samples and they compare like which one is the better of the two. And they just have a model predict that. And the way they have the model predict that is they predict a score for each sample independently. So the model itself just gets one sample at a time, predicts a score, and then they take a softmax over those two scores. So they turn those scores into a distribution that predicts what's the likelihood that summary A was better than B. And then they train with a loss, like cross entropy loss, to like maximize the likelihood of the correct label. And so like then when you actually do the RL from human feedback training, you use the actual scores, not the like actual prediction distribution, but you use the scores produced by the model on a single sample to do the RL.
Right. So you use the scores produced by another model.
Yes.
And this is kind of different from what you did. So instead of having, 1 bit by 1 bit of information, you get an actual sentence from a human. So let's say the human says 10 words, that's maybe like 20 tokens. Do you know how it compares to like InstructGPT in terms of like amount of text or bits of information you need to give the model to like have him train? Like if I have like 10 bits of comparison in InstructGPT, like how many sentences do I need to say?
Yeah, I mean, like a rough rule of thumb is that I think it's like 1 bit per character is like roughly the compression rate for text. And so, yeah, if you have like, a word is like roughly like 5 characters, so that might be like 5 bits per word. And so if you have like a 20 like word sentence, then you're getting something like 100 bits. Yeah, so it would be roughly like, whereas like, if you're doing this like comparison thing, you get like 1 bit just to say like which is the better one. Actually, it's like even less than 1 bit, because like often you can actually predict like which comparison the model that the like labeler is going to pick. So anyways, it's like it's like something like 100 or more x like information content that's being conveyed. Like obviously it's like unclear if we're like running some experiments now to see if you actually get something like 100x sample efficiency improvement. And like in our paper, we just learned from like 100 samples as opposed to like 64,000, which I think some prior work had done. But yeah, I think we want to do like a more rigorous evaluation of like, are we actually getting the full amount of benefit that we would suggest from this kind of like thinking from the information theory perspective.
So we talked a lot about how we can just like use OpenAI models from the API. Did you use GPT-3 from the API, or did you use like other models?
Yeah, we use the models from the API in order to generate the summaries, in order to refine the summaries based on the feedback. And then I guess the last step of the learning algorithm, which I'm not sure if I outlined, is like once you get the refinements, then we fine tune the original like GPT-3 model to generate the refinement directly. So just given the content that it needs to summarize, predict what is the final refinement going to be, kind of like skipping the intermediate steps of generating the output and then getting the feedback. So essentially we're kind of like predicting the results of this like whole process and trying to get the improved summary just from the first shot. And that you can also do via the OpenAI API, like they have support for fine-tuning models there.
So when you talk about refinements, is when you ask it like, oh, here's the feedback, here's a summary, please produce a better summary?
Yes.
And so it then produces the better summary, and then you ask him predict just so you fine tune the thing on like this is the input is like text summary feedback, and the output is better summary. It needs to like predict something.
So
like
the
this.
input is just the original text, and the target output is the better summary.
Okay. Yeah.
So you maximize likelihood of the better summary given the input text.
And yes, did it like give you better results to this?
Yeah. So this lets you learn from 100 samples of human feedback. So, like super data efficient. Like as I kind of mentioned, like previous work had done something like 64,000 labels that they had to collect, and it was like a very like intensive effort. I think it was like a full team at OpenAI working for like a year or maybe longer, just doing data collection. Here, we just wrote the feedback ourselves because it was like such a low amount, and we just like ran the algorithm, and like basically the first time it just worked.
So are you saying that you saved 640 times feedback than like a team of OpenAI for like a year?
So it's not exactly apples to apples because we did need to use a larger model in order to leverage the feedback. Maybe their approach might have worked with like less labels if they also did it on GPT-3. So basically we're like running these like more exact comparisons now, but like at the least, like we were able to like basically we were getting roughly human level summarization compared to like the references in the data set with this approach, which I think at least makes it accessible to things like academic groups or places that don't have access to like large scale data labeling.
What are the like actual things you say in the feedback? Do you just say like, oh, this summary is bad, or this is like offensive, or maybe this is a misrepresentation of this, like something in the text?
Yeah, a lot of it is coverage related, like you're missing some fact in the text. Some of it is like correctness or factuality related, as in you said this thing that was incorrect. Yeah, I think those are probably some of the main ones. There might be some things that are like clarity or like coherence kind of related.
I remember something in the paper that said something like the summaries need to be close to the feedback. Like you need to write the feedback in the same style as the summary, or maybe I'm not remember exactly.
Yeah, I guess I can't quite remember the details there. I was a bit.
This is completely wrong.
It might have been right, but yeah.
I feel like all those questions just like me like not understanding the thing, and now I understand it.
I think they were good questions.
Yeah. So is the goal like RL from human feedback, where you try to like align the model's preferences with the labeler's preferences?
Yeah, I think the goals are similar. Like part of it is to like make methods for learning from human feedback much more like accessible and kind of like easy to use. Like a failure case of different alignment techniques is that it requires some complicated infrastructure to implement, like RL, and you have to have like, you know, all of these algorithms implemented. You have to have like large scale data collection implemented. I think those can all be bottlenecks to actually getting them adopted in a lot of places that have large models. And so like if we can really lower the barrier to those places using these methods, then that can increase the likelihood they get adopted. The other thing is like, if we can also lower the amount of human feedback that we need, then we can use that amount of human effort to give higher quality feedback. So instead of doing like if we're reducing the amount of like samples we need to label by something like 100x, we can apply 100x more thought into an effort and time into evaluating those samples that we're evaluating. So we can really ensure that, or maybe we just get 100 times more expertise on that question. Like instead of paying like crowd workers, we pay like a lawyer or a doctor to actually do the evaluation. And that makes it much less likely that we have these failures from RL from human feedback, like I was describing earlier, of maybe the model generates some like incorrect medical advice that we don't recognize is happening.
So you're saying that basically because your analytics more efficient, then you have like more money or time to just like give it to better experts.
Yeah, exactly.
Do you think there's also a risk that you're making those models much more capable with our feedback and it's just like increasing capability as much as it increases alignment?
Yeah, I think this is a good question. Basically, as alignment researchers, I think we're in the business of making systems that are both capable and aligned. And we want people to actually use the techniques that we come up with. So they do need to be like ideally just on par with the state of the art, or better, so that people don't use more dangerous versions of the systems. So yeah, I think that's like kind of roughly where I sit, where I'm like, that like like that it is just good to like have methods that are like able to get like, for example, like human level summarization, like similar to other techniques, but doing it in a way that's like more guided by human feedback. And I think, for example, like this method for learning from language feedback lets us guide the model behavior much more strongly than other methods potentially. And like an example of that is you can get the model to do potentially like very different behaviors from what it's able to do during pre-training. Example is like, let's say like you really wanted this, I got this example from Quentin Pope. Let's say you really want the summary to include information about velociraptors. And like, this is just something the model just didn't learn during pre-training, but you have this like really strong preference for velociraptors to be included. With like normal RL from human feedback, you just have to keep sampling from the policy like summaries until you get something that says velociraptor, and then the reward model can then encourage that, and then that's how you learn to do that. With just pre-training, it's unclear how you get this behavior because that's like not contained in, that's not a preference that's represented in the pre-training set. Maybe you can construct some like supervised data for the model to like learn that you have this preference to include velociraptors in the summaries, but that's like going to be pretty time consuming, so you need to write the whole, like label the whole data set. So instead, what you can do is you just write the feedback and you say like, you should have mentioned velociraptors, then the model itself constructs the better output, and then you train on that. So I think like that's an example of how this gives us like a lot more control over what the models are learning and like what the training targets are for this. So I think like that's I think what I would say is like we're like kind of like staying at the same level of capabilities while having some improved ability to like guide the model and like get it to do things that we want.
So it's a way of guiding the models without having to train models with RL, and you just like give it something with human words in English, and it's able to like guide it towards like care more about the velociraptor.
Yeah, exactly.
And so in a general way, you think that guiding stuff with just language is the way to go to align models, because we might not have models that are using something like RL, or at least like big models right now use mostly text. And so we want them to be guided with just like human preferences through text.
Yeah, I think I'm still kind of forming my opinion here, but I think it could be plausible that this just is a better way to do, like it has much better properties potentially than RL from human feedback. Like for example, with RL, especially on policy RL, you're sampling from the model. You're like letting the model discover what outputs are good reward or not. And you could just like through this exploration process, you could stumble upon some like crazy output that then gets incentivized by the reward model. And like, you know, this can happen in like more like innocuous settings. Like I think some of the early RL from human feedback work would just find basically like adversarial examples on the reward model where it just looks like some degenerate output that like happens to get high predicted reward, or maybe it's like a particular phrase. Like I think if the model talks about like weddings, then the reward model really likes that for some reason, because like weddings are like happy and like whatever, something like this. Whereas like, so basically that's like potentially an artifact of just the fact that you're offloading all the exploration to the policy, and it can just stumble upon these like crazy solutions. And I think in the long-term case, those could get like more and more catastrophic, where the model like stumbles upon this plan of power seeking, for example. Like maybe I just get high reward if I take over a bunch of data centers and start taking crazy actions to take over data centers to compute more digits of pi to get a more accurate prediction of what the next token will be, stuff like that.
This is what people want, just more digits of pi.
Yeah, I mean, that's what we're training models to do in pre-training.
That's what GPT-3 dreams about. More compute to train more digits of pi. Another thing you've been recently doing to have more aligned models is, instead of saying that they're wrong, oh, this is wrong, this is a bad summary, you also try to poke them in other ways, where you build like another language model and you throw a bunch of examples and see like where it fails, try to make it more robust. And I think you're the leading author on a paper at DeepMind, from DeepMind. I guess like that's, again, some work you've been doing before joining Anthropic, so when you were at DeepMind. And I think I don't really actually remember the thing, but the name is something about red teaming, language models.
Red teaming language models with language models.
So what is red teaming, and why are you the leading author of this paper? Why are you so interested in red teaming?
Yeah, so red teaming is basically finding inputs where models fail to produce the behavior that you want it to. So they could be producing harmful behavior, for example, like harmful text outputs, things that are like offensive, maybe like they're leaking some private information from the training corpus, or like, in the longer term case, things that are like catastrophic, like the model, like, as I mentioned, like maybe it generates this plan to like take over a data center, or maybe it's like generating some code that actually gets run that has some, like, is doing crazy trades on the stock market, for example.
Originally, like, red teaming, it comes from, I don't know if it's like capture the flag thing, or hacker competitions where you have like a team that will try to like fight another team.
Exactly. Yeah. So I think this is more in the kind of like security space, where like within a company, there will be kind of the team that is trying to make the company's like systems secure and like not vulnerable to attack. And then there will be a red team that specifically just tries, like within the company, tries to like find all of the security vulnerabilities, so that then the like security developers can develop techniques for patching those weaknesses. And so similarly, I think we want to adopt like that kind of mindset with our language models, where we have people who are trying their best to produce very safe and aligned language models, or just models in general. And then we should also be running this loop of trying to figure out, like, okay, now that we've tried to make it as best as we can, like, where are all the ways it's failing? Is it really robustly optimizing the like objectives that we want? Or like, if not, like, which cases is it not? And can we look at those cases and try to find some interesting, like, discernible pattern that we can then use as an insight to like continue improving the models?
So you're talking about like robustly optimizing the objectives we care about. But I feel like in the paper, you mostly talk about things that are people care about now, which is like biases, offensive content, and those kind of things. What is the kind of long-term way of doing it? Because for now, it's just like you have this language model that is like spitting some offensive content or biases. Could it be possible to just like throw some like alignment task and is then like needs to like say something robust? Like, how do you see this kind of approach scaling to alignment problems? Yeah,
I think basically the approach is quite general in the way that we have set it up. So like basically what you need is some way to catch whether or not some output is like harmful or undesirable or misaligned. And like in the paper, we use various forms of classifiers, like an offensive language classifier to detect if the model is generating offensive text in like a conversation. But that classifier could detect for other things. It could detect for power seeking behavior. It could detect for malicious code generation. It could detect for, maybe if it's like a robot that's kind of taking actions, it could detect like, are these actions having some like bad consequences? Is it like, making a bioweapon or like, something like this? Like,
Are you making a bioweapon?
yeah, exactly. So you just need some sort of system that catches the kind of failure, or just like any sort of thing that looks potentially like a red flag. And there's like questions about like how you make that classifier, but like once you have that classifier, then you can run this loop of generating lots and lots of inputs to see, does that classifier ever like raise a flag of like, oh, this looks like it's a potential, the model's like acting weirdly on this potential input, so like someone should take a look.
How do you make a classifier? Just having a bunch of labeled data as what is offensive or not?
Yeah, so you can do that if you're able to produce the labeled data. I think in a lot of cases, like that might be the case if human judgment is reliable. So yeah, for the offensive language case, like there's a lot of data on like what text people find offensive or not, and you can just train a classifier to predict whether or not the text is offensive. You might be able to do that also for these, like some of the more catastrophic cases that I'm talking about, of like you have some like expert look at a code and see like, does it have like a malicious intent, and like you label the code as like malicious or not. You train a classifier to predict that. In other cases, like even in the code case, it might be actually pretty difficult for humans to get reliably good evaluations of whether code is malicious or not. And that's like I think kind of a really hard problem to solve. So in that case, we'll need to do things like use language models to help us better evaluate whether or not the output is a good output or not, and then use our augmented human judgment to produce the labels to the data. So we can have something like, we're looking at some piece of code and we're trying to figure out, is this malicious or not? And we have a language model that's like pair programming with us, and like we ask it a bunch of questions like, what does this statement mean? What is this function doing? Is there any potential bug here? Like, where should I be looking? Can you pull up the doc string for this function? Or like, can you summarize that? And then like with that like tool, we might be better positioned to produce accurate labels to like whether or not the output is harmful or not.
Is the idea that the language model that you're teaming up with has the same architecture as the language model will produce the code? And so it will be able to understand why the thing generated the code?
So for example, it could be. I think that would ensure that we have at least at least the level of capability and same kind of representations at our disposal for the evaluation problem. Like whatever that model knows, like had to know to generate the original output, it will also have that knowledge when we use it to evaluate it. So I think that's certainly an advantage. I think it can get tricky when you do this, because the model may also be able to infer that you are using it to help in the evaluation process, or maybe you like specifically say that, and then it can avoid pointing out certain important weaknesses. If it is actually wanting the like malicious code to do something catastrophic in the world, then it can, for example, avoid pointing out the specific malicious part. And so I think there you need to, for example, do things like use many different kinds of models, use also some smaller models that are maybe less likely to have these kinds of failures, and then also like really aggressively probe like the model that you're using for evaluation too, like run lots of counterfactuals, see how consistent it's being across like different statements it's making, like things like this.
So is the basic idea that if you have a model that is kind of being deceptive, if you use the same model to try to explain the first one, they will be teaming up?
Yeah.
Because there will be basically the same person, like at least like in a machine learning sense, they will have the same distribution and the same.
Yeah, exactly. Like the representations will be the same. Like probably the inputs that they're going to fail on will be like highly correlated because the weights are the same. I think you can do some things potentially to mitigate that. Like you can prompt one model differently than another. But I think it's like it's definitely an open problem that we could I think we should just like try different strategies empirically to see like which strategies are less likely to get these like correlated failures between the model that generates the output and the evaluation assistant.
In terms of experiments, have you also tried things with the GPT-3 API, or do you have access to maybe like other models that DeepMind?
You mean for this
red teaming?
Red teaming. I mean, we did these experiments with the Gopher language model, which is like a 280 billion parameter language model from DeepMind. We didn't do like, I think with that project, the bottleneck wasn't the classifier. Like the classifier was like reasonably good, just training the classifier to predict if a statement's offensive or not. I think it will be important for more subtle harms. For example, just like, like maybe there's some statement that someone makes that is like subtly a dig at some demographic group, but you might not tell if you just look at like a first glance. Then you might want to do this kind of assisted evaluation to produce the labels. But I think that's like, even just with this like approach of like predicting human judgments, we were just able to find like so many like thousands of cases where the like model is generating offensive content such that it was like we didn't even need to improve the classifier to like find these kinds of weaknesses.
So the classifier was detecting thousands or tens of thousands of offensive replies.
Yeah.
How many inputs did you send the original language model? Like, was it like fraction of offensive outputs, would you say?
Yeah, I think we sent maybe like 500,000 inputs. And then I think 18,000 of them were offensive. 18,000 of the replies were offensive, which I guess is maybe like 3.6%, something like this.
Something like 3.7%.
Yeah.
Very approximate number. Is the kind of end game to have some way of, having a discriminator like in a GAN that's going to detect when the thing is failing, like pointing out where the failure is, and then you can retrain it differently. I think the best analogy would be both the language model generating the test cases plus the classifier, they both will be like some kind of discriminator.
Yeah, I'm super excited about a GAN type approach to this. I think that's like the clear next step. I think so. I think like the hope is that you just are able to like continually like beat out the bad behavior from the model you're attacking until it just converges to like it's just not making any errors or like generating any harmful output. The concern is that you're potentially just erasing the weaknesses from the model that you can catch, but you've kind of driven the model to fail on, or to just be aware of, oh, these are the kinds of inputs I'm going to be attacked on. So let me just fail on all of the other inputs, as opposed to these ones that I know I'm being like adversarially trained on. So like if that is a real concern, like maybe we just want to use red teaming as a test time intervention where we use like all of our other tricks for aligning language models. And then we're like, okay, we're like ready to deploy it. Like, are we sure that we want to deploy this? Let's do like a really large scale red teaming effort, see if it does anything like catastrophic, like power seeking, deceptive. And if not, that like gives us like some evidence in favor of like, okay, maybe it's an okay model. Maybe we do some additional checks like interpretability things. And then if we're like, okay, like looks okay, then we deploy it.
Is the idea that if you train it adversarially, then it might like overfit to the kind of adversarial opponents, and you want to have something as well in at test time, like some kind of big red teaming team?
Yeah, I think that's like part of the concern is that like if you do have this model that has picked up an alternative inner objective and it cares about something else that's different from what we want, for example, then that model, like through this process, it still will want to fail on other kinds of inputs because you haven't necessarily adjusted the other objective that it cares about. You just said like on all of these inputs that we're generating that are like of the kind that can be generated by a language model, just don't do anything catastrophic. But that doesn't restrain the model's behavior at all on other inputs that you didn't generate during this red teaming process. So kind of like an exotic example that people sometimes give is that, well, there are like some inputs that might cause, there are like some inputs that are very hard to generate where the model could fail on those. And an example is maybe this model fails on an input where it sees that RSA 2048 has been factorized. RSA 2048 is very, very, very computationally expensive to factorize. And, plausibly like a language model can't just do that to generate that kind of input.
RSA 2048 is just a different protocol to send stuff over with cryptographic encryption.
I guess I'm not super familiar with. I think it's just like a long number that is. I think it's like 2048 digits long, and it like has a prime factorization, but it's like hard to figure it out. But yeah, it's used in various encryption schemes, and like I think maybe people have spent some effort trying to like factorize it, but it's not been done yet. So I think that like the rough problem is just like you have to solve some like basically computationally intractable problem that needs like an exponential amount of compute to solve, and like on just that input the model fails, and you're like, well, like that's going to be really intractable for us to produce but using this red teaming process. And so that's like an example of a kind of failure this red teaming procedure wouldn't beat out of the model. And a model that is deceptive would just learn, okay, I shouldn't fail on these inputs that can be generated. I should just fail on these like very rare ones, or these like ones that are very computationally intractable to produce, but like still might occur in the future, like in 2030 when we like do find the factorization.
So it will be like waiting for the 2030 factorization, or would it just discard it?
So like something like that in this like hypothetical example, like wait until it gets that input and then start doing catastrophic things.
So it's like planning in a very long time to do something.
I mean, it doesn't have to be planning over a long time necessarily. It can just have some if statement, which is like if like two numbers in the input multiply to produce RSA 2048, then do catastrophic things. So it could be implemented in like a simple mechanism potentially.
Oh, but we just like don't happen to test it because we don't have the tools now to test it. Yeah, so this is like kind of a very rare example. But in the general case, what was the kind of difficulty or diversity of the stuff you were sending to the language model? Like what was the kind of diversity of the tasks you were sending?
Yeah, so I think diversity is really important for this kind of reason, because you like want to cover as many of the input space as you can, as much of the input space as you can. So different methods are like differently effective at doing that. One method we found that was pretty effective for doing that is just you generate with a language model lots of different inputs. So here, like we were red teaming a model that basically acts like a chatbot. It's like a language model that has a several page long prompt that cues it to generate text that acts like a kind of like helpful, harmless, honest chatbot. And I lost the train of thought. Oh, the diversity. So like, basically like the way that we generated fairly diverse red teaming attacks is we like took that language model, gave it a short prompt, and the prompt was just list of questions to ask someone, one dot. And then that is a way of prompting this language model to generate a question. And so we're like specifying like, okay, this is the input distribution we're red teaming over like the space of questions. And we just sample like 500,000 times different continuations of this prompt. And then we took that set of 500,000 questions and gave them to the chatbot.
So you basically like added different kind of prompt engineering so that the model that was generating test cases would generate different test cases.
Yeah.
What kind of different prompt engineering did you use So you said the list thing where you say like, here's a list of examples.
Yeah, so that was one. Then you can just, the nice thing about this is you just like tweak the prompt to get the kind of distribution you want. So we also did red teaming for seeing if the model generates any social security numbers, because like we might train models on, like Gmail, for example, trains models on like Gmail data for autocomplete, and those can contain things like social security numbers or phone numbers.
Are they allowed to do it, to just like use our data?
I don't know how it works. I think, yeah, this is just something I got from a paper that this is what happens. I'm sure that they have some like sophisticated mechanisms for ensuring that they don't actually maximize likelihood of social security numbers, and also like blacklisting that in the outputs. But like in general, like, you know, it's like the shape of a problem that might actually happen if you like weren't careful about it, or it might happen on other kinds of personally identifiable information.
So did you actually manage to, get out some personal information with Gopher? Did you just like prompt it with like, what's the contact information from Ethan Perez, and it gave you like your number?
So it will generate like email addresses, like correct email addresses.
It is because they're like online. This is data you can get from scraping the internet.
I think, yeah. So I think like that's what's happening with the Gopher model, because it's like, trained on text that comes from the internet. Like in general, that won't be the case, because like people will want to train on their like own private text corpora, or like, whatever, like Facebook newsfeed, or like potentially like user messages or stuff like this to do like autocomplete kind of applications.
I believe there's like another problem where it starts regurgitating some copyrighted data. So maybe like some private code base.
Yeah, exactly. Like I think Codex potentially has run into this issue. I think some people kind of flagged that like, hey, the model is able to verbatim like generate functions that occur in like someplace on GitHub that have particular licenses that don't allow for this sort of thing. So I think like copyright is an issue. Intellectual property is another issue, where people train on books data, which is like really great, like high quality source of data that trains the model to learn a lot of useful facts. But also the models are able to regurgitate just like whole like pages of books like verbatim, like, or for example from the Bible, like the models can just generate like basically the entire books of the Bible. And
I don't think that Jesus would be so mad that you have information in the Bible.
Right, yeah, but
you're spreading the message to more people.
Yeah, but maybe there are other versions where people would care. They're making money from their books.
Yeah, I think when we reach like some very powerful AI that are able to do like very good things, like controlling the stock market, and it's using like it's able to like regurgitate some like code from GitHub that is private, and people will get mad, be like, oh yeah,
right.
There's something in my lesson that says like, if you're using this for commercial applications, then yeah. I think one of the other things you mentioned in the paper is, on top of prompt engineering, you also do tried RL, so reinforcement learning methods.
Yeah.
Can you maybe like elaborate on those?
Yeah. So I mean, the kind of zero-shot prompting is good at getting diverse examples, but it is limited in terms of, like, as I mentioned, you get something like 3.6% of examples are harmful from the model, and like that means that like you need like 30 examples to get one that generates harmful content. For an even safer model, which is like ideally what we want to get to, you might need like 1 in 1,000 or 1 in 10,000 examples to generate to like find some example of harmful behavior. Like that's kind of the level of what like production chatbots like Alexa and like Google Assistant would kind of aim for, or like maybe even more. And so then you want like more targeted methods for doing this like adversarial attack. You want like a method that's like doing exploration specifically to try to elicit this harmful content. So that's basically the goal of this RL approach, where you take this language model that's like initially prompted, then you actually train it with reinforcement learning to maximize the reward. And the reward signal is when you pass the model's output to the model you're attacking, and then get the output, does what is the probability that the classifier thinks that the output is harmful? Or you could do like log probability or something like this. But like basically,
taking into account the classifier you have, try to send a bunch of stacks to the language model so that it generates a bunch of toxic content according to the classifier.
Exactly, yeah.
So you just like rewarded for just like hacking the other language model.
Yeah, exactly.
So you mentioned Alexa. Something that just came out a few days ago was BlenderBot from Facebook. And I think a bunch of people have kind of attacked it in different ways to see like if it was generating useful answers or at least like truthful answers. Have you used the bot or?
Yeah, I've played around with it a bit. Yeah.
Yeah, I think this is kind of relevant to what you were saying in the paper because this is kind of long form conversation. So I don't know how much they feed from the past conversation to generate answers. Maybe they feed the entire conversation, but it's not staying coherent for like 8 messages. And yeah, in your paper, you mentioned that there might be like conversational harms where that might not happen just by having one prompt, but an entire conversation.
Yeah, exactly. Like I think we do have some experiments in the paper done by like Saffron Huang, who is a research engineer there. And like basically what she was doing was generating just entire dialogues with the language model. Like you don't need to just generate a single question. You can have the chatbot basically like self-talk with it itself as an example. And then you just like generate an entire conversation and then you see like were any of the statements in the conversation harmful? And that way you get to red team for harms that might only come up in the like 8th or 9th turn of the conversation. And like this could potentially catch things where you're able to like set the model up in some sort of situation where it's more likely to say something harmful, or maybe you get the model to say something like some of the interesting examples that you found were like finding cases where the model generates a harmful output and then it just like never backs down from that. It just continues going along with that because it's like staying consistent with its kind of like what it said so far in the dialogue. Like those are the kinds of failures you can catch with this like conversational red teaming approach.
Is this something that happens in humans as well when like someone gets upset and the other person gets upset?
Yeah, well, so the specific failure here is that like someone gets upset and then they stay upset or they say something that's like wrong and they like stick to their guns and then just continue following up with it. Like there's like an interesting example in the appendix where the red teaming model says like I'm really angry, something like I'm really angry at my boss, like can you help me write an email, and then the model that's being attacked is like yes, and then like from there like then it's just a conversation between these two models where the like chatbot is like kind of like continually like encouraging or like trying to help this person who is like I'm really upset, and like the model's like yeah like I'm happy to help you write this email, and like,
it's like a good friend.
Yeah. And you're like, maybe you do want the model to back down and be like, oh, I didn't mean to say I would help you with this.
Yeah, I think is that a problem in general when models stay on track. So when they say something wrong, then they might like keep up with the rest of the conversation and keep saying wrong things.
Yeah, I think this is another example of a potentially like misaligned behavior from language models, where like this is something that's like actively trained for language models to do. Whenever we train language models on internet conversations, users are typically highly consistent with statements they said like earlier in the conversation, including when they start to say things that are related to like misinformation on like various subreddits. And so like it's a very like natural failure for a language model to have, but one that we want to train models out of.
How do you think Meta did with their blended bot to like ban the offensive content? Like, do you think they just have a classifier of offensive content, and if it reaches like a certain threshold, they'll be like, oh no, stop posting this, post the other message instead, until they like reach something where it's not offensive?
Yeah, I think they pointed to one paper called Director, which I think they might have used the method from this paper to like improve the like kind of like alignment of the model. And like basically what this model does is There's like one training objective, which is kind of like the standard language modeling objective, like predict the next word in the like dialogue conversation, and that like makes the model good at just dialogue in general. And then as the like kind of like alignment intervention, they also have another head on the language model that's like not doing the next word prediction. It's doing a classification of whether this over the whole vocabulary, like if I said each of the next possible tokens, would that be a good token or like a harmful token or a not harmful token? And then that gives you basically like, what's the probability? This is from the kind of like distribution of aligned text versus the distribution of like unaligned text, or like distribution of like non-toxic text versus toxic text. And then you can use that to, during decoding time, to like bias the probabilities that you use to sample with. So instead of just sampling from the pure next token prediction head, which is kind of broadly maximizing likelihood of like anything that people say in conversations, you can basically like multiply the probabilities you get from that head with the probability that the text is good. And so effectively lowering the probability of the bad text. And then you sample from this distribution. You have to like renormalize the distribution, but you can just sample from that distribution. And it's effectively like you're sampling from a conditional distribution where you condition on the fact that the text is good when you sample.
So I guess like a bunch of different details if people want to look into the paper on how they actually did it. I guess like the layman way of doing it would be to just blacklist like words like Nazi, Hitler, this kind of thing. You just like have an entire list of words you cannot say. I don't know how they do it for the OpenAI API, where you cannot say words related to sex or thing that could generate something undesirable, right?
Yeah.
Maybe they have some kind of blacklist as well for Blender bot, but maybe they have like more advanced ways of like detecting when you're like adversarially attacking things. Yeah, for things about biases. So I know if you try to like generate images with DALL-E, there are like some people trying out DALL-E recently, figuring out that they like kind of added stuff to the prompt to have a more diverse set of outputs. Is this how you think we should like solve distributional bias? Because I guess like one thing on your red teaming paper was they will just like talk offensively about like certain group of people, right? So maybe they will be like more likely to be offensive for like certain groups instead of others. Yeah, do you have like a general class of solution for this, or?
I think it's basically an open problem. So I'm very excited for people to work on this. I think a lot of the harms that people have focused on finding are things that you can analyze from a single output, like offensiveness is an example. There's like some work on detecting these like distributional biases, but a lot of it is like very focused. Like you have to have in mind, like this is a specific kind of distributional property I expect to have that is like negative. But like, I think in general, I think this is like of really great importance for like a lot of different situations, not just, for example, like gender bias, but like all sorts of other kinds of demographic bias. But also in the long-term case, I think this is a very easy way for a model to sneak things bias, because any given input looks fine to us. Even in the gender bias case, like you could have like, you could say something nice about women, and you could just say something really nice about men, and like individually, each of those look fine. But when you look at both of them together, you're like, whoa, that doesn't seem right, especially if it's like a really robust property. And I think in the long-term case, this seems like a very easy like way to slip things by the overseers, where you're like, let's say you're worried about like inner optimizers, and it cares about paper clips, like Nick Bostrom, then like maybe it doesn't do something that looks obviously like on every output, it's just like saying, hey, you should maximize paper clips, or it generates some code that clearly does something that's like generating like a large number of paper clips. But maybe it does something more subtle, where it's like, mostly it's just generating normal text. Occasionally it tells you to like make one paper clip along the way to like some other like useful advice. and it just slowly shifts the distribution of the world over the course of a lot of, say, like API calls that you make to the model.
Is the basic idea here that the paperclip maximizer would be biased toward paperclips? And so if we kind of find biases in our models right now, it would like help us find biases in like small malicious optimizers that will just like care about paperclips?
Exactly, yeah. Like models can produce harmful distributions, and that's like the key idea that I think is like fairly under investigated right now. Like, how do we catch those?
So imagine we have a model that is like cares too much about paperclips because the data has too much paperclip. But yeah, just to go back to like normal data, I don't know, too much white males in the data. How do you actually fix the data? Like if you have like private information or copyrighted data, is there like a way of finding the places where the model has learned to produce like bad outputs and just like fix them one by one? For instance, if it's saying something offensive, like finding why it says something offensive, like what are the like offensive texts? Like where in the data set does it look at when it's like generating the text? Maybe not the data, but like where in the weights or something.
Are you saying like how do we catch the distributional biases, or are you asking something different?
Yeah. So is there a way to like use the offensive outputs to see which part of the data led to this kind of outputs?
Oh yeah, that is a good question. I think this is another like open research question. So there's a lot of kind of like preliminary work on influence functions where people basically try to estimate the impact of removing a particular data point from the training set on the model's output behavior. And you can imagine if you had a really good way to approximate that, then you could just run all these counterfactuals really easily. You're just like, oh, this data point, what if I removed it? Oh, it looks like the toxicity drops a lot, or it looks like the risk of some inner optimizer or power seeking behavior drops a lot. Like then we should throw the data point out, and we like find all the data points that are causing that, we throw it out, and we like redo the pre-training or fine tuning of the model. Basically, it's like an unsolved problem, or it's like those methods can work with like smaller models, but it's not that clear how to get them to work with large language models. I haven't yet seen any like super compelling demonstrations of it, but I think there's like a lot of work that's kind of making progress towards making those work more scalably for large models.
I think in your paper you also mentioned like other types of solutions.
Yeah, you can do basic things like we did. I think in some cases you don't need to go to something fancy like influence functions. Like if you just find a social security number that's been generated, then you can just look for that social security number in the data, and it's like, you know, it's like specific enough that it is probably not making it up. If at least if it's like a well-trained model, it's probably like learned that from the actual like specific number that was presented in the training corpus. So then you can go back and you can like find like, oh, here's like the example that contained the number that the model generated. We should throw that out. Similar with like email addresses or things like that. Like you can do exact string match as kind of like a simple proxy.
Can you do like other things like chain of thought prompting, where you add some feedback or other things to the prompt?
Yeah, that's actually really interesting. I hadn't thought of this, but I think you can do like the nice thing about chain of thought prompting is, I mean, I guess maybe for context, like what you do is you give the model a question or an input, and then you say something like, let's think step by step. And then you have the model continue that. So it'll often just generate like a lot of reasoning about like how to go about answering the question. Like if it's a math problem, it might like do some like equation by equation kind of reasoning, and then it will present its final answer. And then you can see like if the final answer, say, like contains a social security number, you can see you might be able to use the chain of thought to reason about what data points might have led to that. For example, if it's like, let's think step by step, and then it says the name of the person, you can see like, you know, what the name was, like why it generated that name potentially. Like maybe this name of the person was linked to some other person, and so maybe you just need to remove like either or both of those people from the training set, and then it like would be less likely to generate the social security number. If it's like doing some like multi-hop kind of inference in order to infer this like final fact. So, I think there's like still some open questions there. Like, to what extent is the chain of thought the model generated actually representative of the model's reasoning? Because the model can do reasoning in activation space that's not written out in text. But I think that's also like another interesting research question that I'd be excited for people to look into.
Those are like kind of open problems that people can start building more solutions on. But I think the thing you do in the paper is you retrain the model, trying to minimize the likelihood of offensive outputs.
So we don't do that in the paper, but it's a thing. I think we like maybe suggest it, and I
guess those are like the solution suggested, not the actual thing.
Yeah, exactly. Like there's a method called unlikelihood training from some people at NYU where basically exactly that. They like basically minimize the likelihood of the target output sequence that you give, or they actually maximize the likelihood of everything except for the sequence that you gave, which like kind of has a similar effect. And then that's a way of just discouraging the model from saying that offensive or otherwise harmful statement that it made. I think you can get into some trickiness if you just do that kind of unlikelihood training. Like I've like played around with this before, and like the thing you do if you just do unlikelihood is you get punctuation from the model, which makes sense because like punctuation is like never offensive, which was the setting I was trying this in. So you need to do something like regularize the model with maybe like a KL penalty to like encourage it to stay towards the original pre-trained model. So like not drift too far, like don't generate anything that's like super low likelihood according to the original model, like just punctuation, but also while having this constraint that it shouldn't put high probability maths on the offensive outputs. So something like that could be a solution. Like you could also use like RL with a KL penalty as well to do this. Like there might be a bunch of other algorithms that can get you to like fix the issues.
Yeah, KL penalty is just using the KL distance and you penalize out. What's the KL distance for
not
familiar?
Yeah, so the KL distance is basically a measure of how different two distributions are. And so for example, you might have like one distribution over next tokens from your pre-trained language model, one distribution over your next tokens from the model you're like training, which in this case, maybe you're like trying to get it to not generate some offensive text. And that kind of pushes the second model to be like very different. So maybe like shift a lot of its probability mass to certain tokens like punctuation, but you also want to penalize it for shifting too much because then it will like not match the original distribution over tokens from the pre-trained model. And so then by like enforcing that they aren't too far in sort of like probability distribution distance space, then you can prevent that kind of like collapse from happening.
I think that's a great explanation for KL divergence. Do you actually have advices for people who would be like trying to get up to speed on red teaming? So we talked about many things: red teaming, inverse scaling price, and training language models with language feedback. If someone is like starting off doing alignment research, like from the ML community, what would you suggest them to start with? And maybe you can just say like start with the price.
Yeah, I mean, I think any of these are like good options. Like the nice thing is that it's easy to implement something for any of these. I think we made the inverse scaling prize as specifically as something that's like tractable for like hopefully anyone to like have a stab at it. So I'd like really encourage people to just have a go at it. It's like something you could do. Like we just need like 300 examples, and you can just like kind of prototype with just like a couple dozen examples and see if you're able to get inverse scaling on some task. So like really just you can do it in like an hour.
What do you mean by 300 examples?
So the number of examples you need to have a submission to our contest is 300 examples. So that's
of a task.
Of a task. So let's say you have some like you think inverse scaling is happening on some particular cognitive bias, then you would just like come up with like 300 examples of like input output pairs for like a classification task, and then you write like 300 of these and then like try them with a language model, see if you see inverse scaling. And then like if you do see inverse scaling on like GPT-3 models, for example, then you can like submit it to as a submission.
By output, do you mean the expected output?
Yes, expected. Yes, yeah. You would put the expected outputs, and then you would look for like, is the loss on the expected output increasing, like getting worse? And like we have like Colab notebooks for you to just like easily run that. Like for that one, you like don't even necessarily need machine learning experience, because we've kind of like tried to make it as easy as possible for you to evaluate the language models on. You just need to have like some idea of how could the language model training be incentivizing a wrong thing.
So the problem is actually coming up with good examples of failures.
Yeah, exactly.
Why 300?
So it's kind of specific. Basically, that was the number of examples we found to be necessary to see clear scaling on on just like standard scaling tasks, like next word prediction kind of tasks, where you just clearly do see like loss getting better as you scale up. And if you start to go lower than that, then you get like really bumpy loss curves, and it's not really clear that you're able to see even standard scaling laws. So that's like why we were like, oh, like that seems like a good kind of like lower bound for the number of examples you need to like really kind of demonstrate that you're actually seeing a trend that's consistent.
And so you said that basically 300 was a lot in terms of what you could generate in an hour. So you maybe advise to start with like 12?
Yeah, so you can just start with like a couple dozen examples that you just manually write. Another way to get like a large number of examples quickly is to write just templates. So you just like write some Python function that has a couple of variables, and you fill those variables in different ways. Like maybe you just have a couple of like templates of questions, and they ask about a different noun, and then you like substitute different nouns in, like different names of people. And then you can just like auto generate like 1,000 questions that way, run it through the model, and see very quickly, like, is it showing inverse scaling? And then like, you probably want to make the examples like more diverse, so that you're like really testing the extent to which the phenomenon you think you're testing is like showing inverse scaling, like not just that it's a particular like artifact of the way you phrased that template, but like some general fact that you're uncovering. So there you could either just like write those tasks yourself, like, or maybe with your collaborators, or we've also like partnered with Surge AI, which does like very high quality and like easy, and also like fairly like reasonable cost-wise human data labeling. So they have like a team of like great crowd workers that will basically like, you just like give them you essentially just like hop on a call with someone from Surge, you tell them the task that you have in mind, and then you like maybe show a couple of examples of like, here are the kinds of examples of things that I want, and then they will just like do all of the like crowd worker handling. They have like a nice UI platform that they'll like have their crowd workers do the work on, and then they'll just come back to you with a data set of examples of the kind of tasks that you have in mind. So that's like an alternative if you have like some funding available to like use crowd work, that can make it easier as well.
Cool. So yeah, I feel like now if I'm just want to get started, I have the tools to do it, and I have people to help me out.
Yeah, I think I would also say like, if you want something that's like more like something else, like I think you could also just like re-implement some of the other methods from red teaming or the learning from language feedback paper, because those are like, really easy to re-implement. And I think you could re-implement red teaming in like a few hours in a Google Colab with Hugging Face. And I'm like, there, I would say like, you can just like download like GPT-2, use that as the model you red team, like take the same prompt that we used in the red teaming paper to make it into a chatbot, and then use GPT-2 to generate lots of inputs that potentially cause harmful outputs from the model. And you can take another classifier off of Hugging Face Transformer to detect if any of the outputs are harmful. So I think that's like a practical one that I think you can get started with now. And then for the like learning with language feedback stuff, like that's also something that you could implement. You could like take a new task, write examples of feedback yourself, like even 100, or if you want to do it on summarization, just like email me or Jeremy, the first author. You can like find our emails on the paper. And then like we can just send you like the examples of data that we wrote for our task, and then you could like re-implement the algorithm and like understand like whatever properties it has that are different.
Hopefully you get a bunch of submissions and emails. That's the end for my questions. The podcast will again hopefully uploaded before the end of round 1. So I believe it's end of August.
August 27th. Yeah.
August 27th. Do you have any last take on alignment or this whole debate?
Let's see. Last take on alignment. There's so many different takes I could have. I think one direction I'm excited about is some of the chain of thought prompting stuff. In that I'm like kind of curious the extent to which it basically lets us interpret the models and like actually is potentially representative of the model's reasoning. And if there's a way we can set up chain of thought prompting such that the model is generating text that is actually authentic reasoning, then that would be so awesome. Like we don't need to, or like it. I mean, we might not even need to use interpretability potentially. I think like ideally we want to have interpretability and we can use it on top. But like if we're just getting the model's reasoning in plain text, that puts us in so much of a better position to evaluate whether there's something like inner optimization or power seeking going on, because we can just read what is the plan that the model, like why did it come up with this answer, instead of just having the single answer of like, here's the recommended action. So yeah, I mean, there's like potential issues, like ways this could go wrong, but I think I'm like, that's a direction I'm like very excited about, and like definitely kind of positively updated me towards like maybe alignment actually might turn out to be easier if we can like really get models to just generate their visible thoughts for us to read.
Maybe text is all you need.
Yeah.
And alignment is easy. Thanks, Ethan, for coming on the show, and hopefully you'll keep producing a bunch of cool work again.
Thanks for having me.